Welcome. Welcome. Today we're gonna try Unreal Engine again. This will be the second attempt. Yeah, so NimForUE Unreal Engine. Let me show you the project. Because it's kind of awesome. NimForUE. Oh, there we go. That's the repo, and basically it's a plugin for Unreal Engine that allows you to use the Nim language to just write your game code. So yeah, get the pretty, arguably the best game engine and use your niche language with it. Why not? So this is gonna be fun. There are some playlists on getting started, or showcase at NimConf, even game from scratch. Showcase the plugin, so that's awesome. So how about we get started with a new project? I'm gonna set up a new project specifically for Unreal Engine. I mean, for the streams. And today we're gonna try. Today we're going to try to set the project up, and yeah, we see what happens. So I created like Nim folder in which I already have one Nim set up because I'm literally like in the middle of putting together a video specifically on setting up NimForUE Engine. But we're going to open up a new one. So let's get to our good old Epic Games launcher. And we can launch 5.4.1, the newest available Unreal Engine. Unfortunately, it always shows up on the wrong screen. Alrighty. Let me fit it here so you can see easily. And what? We're gonna go to games. I like first-person view games, so let's go first-person view. In a separate video, I will have an example of how to start it from the blueprint project and convert it to C++ and whatever. Because basically, NimForUE Engine requires the C++ to be enabled in your project. So we're going to go straight for C++. I'm gonna skip the whole ray tracing stuff. I don't know how my computer will fare in live streaming at all. So let's call it Nim Streams. Okay, this will be our name of the project, Nim Streams. And yeah, that's it. Just will be on E drive, Unreal Engine Nim. Exactly. Create. It's gonna take a moment. Can I move the progress bar? I can't. Too bad. So how's everyone doing today? I presume we have no viewers, so I'm asking nobody, but it feels like a appropriate thing to do on a stream. Come on, what's our project that we created? By the way, I encourage everyone to just write comments during the live stream. After the live stream, you can also comment on the video. And overall, yeah, if you like my streams, like them, If you want to see more, subscribe. And on Twitch, you can also follow, because I'm streaming simultaneously on YouTube and Twitch. And I think I will make Wednesdays to be a little bit more of a web dev / JavaScript development, where I would like to actually get something going where we could kind of build on stream overlay for streaming, where we would program our own combined chat for both Twitch and YouTube. This way I wouldn't need to use all those weird websites for overlays or whatever. I could just plug in my own stuff. And yeah, then we could just add some animations, a little bit nicer looking counter than the one that we did in Nim, and who knows. So this is Unreal Engine here, and it also fired up the Visual Studio Code. I mean Visual Studio, sorry. So that's that. We have our project, the Unreal Engine project set up. So what we can do is close the Unreal Engine. The code is all compiled already, so we can close Visual Studio as well. And I don't think we'll need it again. So that's the nice part, because it's extremely slow. Oh, come on. Even closing it is slow. Really? It just crashes? Wow. Well, that's Microsoft for you. Okay. Gone. So what we can do now is actually try to add Nim for Unreal Engine. So here we actually have some basic instructions on the bottom. Clone the repo and run Nimble new setup. But something tells me this won't be enough, but we'll get to it. In the meantime, I also started making own separate docs for the project. So let's open a new tab. This would be NimForUE.pages.dev, and I would like the goal of this series, where we're using Unreal Engine with Nim. I have 3 goals that I would like to achieve. First goal is to learn more on Unreal Engine, because it's just so massive that every time I want to make a project, I just get, I just drown. So by exploring little things and seeing how we can implement them using Nim for Unreal Engine as a Nim, we'll learn how it works in the engine, probably how to work with it in blueprints, how it's implemented in C++, and then how we can replicate it in Nim. So we're gonna learn a lot for each subject. I guess we'll basically be forced to make a deep dive into each subject. So that's the first goal, to learn Unreal Engine. Second goal is to learn Nim. The more we use it, the more familiar we are with it, and the best way to learn language is just to use it and solve various kinds of problems, and gaming has a variety of problems, so that's gonna be fun too. And the third objective for me is, as I'm learning, I would like to expand on this documentation here to just make it a little bit better, okay? So this is a quick docs that I quickly made using Astro. It's Astro Starlight, I believe. They're specifically documentation page generator. So in getting started, I basically copied whatever it is, whatever I found on the for Unreal Engine GitHub page. So why Nim for Unreal Engine? The core idea is to have a short feedback loop while having native performance and a modern language that can access all features Unreal provides. We'll see soon enough that is actually faster to iterate through Nim than through C++ and Unreal. And why Nim? Of course, we know Nim already a little bit, so we know that it has a lot of good stuff in it. So yeah, that's that. But let's go to installation. One important thing. NimForUE engine also comes with a template. It's a third-person template where you have, like the main character is already set up in Nim instead of C++ or blueprints, so you can play around with that. But I want first person, and I want to start from scratch because however we will be installing the NimForUE engine is basically the same way as for any existing project. So maybe you're already working on a game and you are really upset with C++ and want to try something else. Hey, make a copy of your project and set it up with NimForUE engine. Try it out. So there's a template, but we won't be using it. We'll be adding it to an existing project. First of all, we need to make sure that we have Nim installed, and the required version is the development branch, because the NimForUE engine uses some, features that haven't been released yet. So to do that, let me open a terminal. Not that terminal. Let's go to PowerShell, to our Windows machine. Okay. I'm gonna zoom in a lot, and basically I have Nim installed through choose Nim. Okay. So I can type version. I have version of choose Nim and whatnot. Oh, that's version from 4 years ago. Wow. 2 years ago. I guess no updates were required. Interesting. And basically, if you would do choose Nim devel, this way you're gonna install the development branch of Nim language. I'll do that, and in my case, it will be like, oh, I already have the development version. But what I could do is do choose Nim update devel. In this case, I ran that yesterday, I believe. So if I run it today, maybe I'll get a new version. Look at that, download it. And I guess something was pushed into the new compiler. There we go. So if I'm gonna do nim -- version. Yep, I have a version from today. Look at that. So that's awesome. So right now we took care of having the Nim compiler, okay? We have Nim, switch to development version. So what will be the next step? The next step is to basically clone the repository of the NimForUE engine project. And we're going to do that. So let's go to our GitHub repo, and we can just go to here, clone, and we're just gonna go HTTPS and copy the link, okay? So now we would need to get to our destination. I know that I installed it on E drive and EUE/nim. Okay, let's see what we have here. Here we have the new Nim streams directory. So let's go there. So now we are in our main directory of our project. We have our U project and whatnot, our C++ project, all that stuff. So what we need to do is create a new directory, plugins. So we can do make directory, plugins, and make it capital. Windows is weird with capitalized, non-capitalized, so have it capitalized. Let's move there to plugins. Okay. And it's nice and empty here. So what we can do now is git clone. Of course, you need to have git installed to clone the repository, and we just oh, I guess I selected it. Let's copy the link again. Okay. And there we go. Enter. And this way we're downloading the newest NimForUE engine. Okay. We do ls, we can see that we have it installed here. So we can do what we can do now is go to that directory, NimForUE engine. And here there's already a bunch of files. So what the manual is asking us, the instructions are telling us to run nimble new setup. Okay. So let's do that. Nimble new setup. NUE stands for Nim for Unreal Engine. Okay. It's like a little command line tool that will allow us to do a bunch of stuff. So yeah, let's run it. So this is something that might take a long time, and I expect it to actually fail in my case, and I'll tell you why in a second. Let's just get through it. Yeah, it's gonna take a while. So what this setup tries to do is basically NimForUE engine was installed or refreshed or updated or whatnot. What it tries to do is basically look up all the C++ classes and modules of Unreal Engine and automatically generate all the bindings from Nim to Unreal Engine. So you can have an equivalent, it automatically generates equivalent procs for Nim, which you can use to call the actual Unreal Engine procs functions. And, classes and all the other things, actors, whatnot. All that gets translated automatically. That connection goes, is being generated on the go. So if you have some extra plugins that you installed, or maybe have your own code or whatever, all those bindings are going to be automatically generated for Nim as well. So, if you made your libraries and you would like to just reuse them rather than translate them to Nim or something, hey, they will just get plugged in and that's it. No extra work needed. So from that perspective, it's absolutely awesome. It just takes a while to do it first. And there we go, we have a first error. So it failed. Why did it fail? And handle exception. This doesn't say anything, but if we're going to scroll up a bit, I'm actually gonna make it a little bit smaller so I can scroll in time without taking too much. There's a lot of logs. There should be a little bit of red somewhere. Let's see if we can find any red. Huh, no red this time. Look at that. Nothing here. This is unreadable. Ah, there we go. Precompiled header file is from a different version of the compiler, or the precompiled header is C++ and you are using it from C, or vice versa. So this is basically, and somewhere around here you can find some like VCC or whatever, that kind of stuff. So just in case, if you go to either the docs that I made, you can click here to go to so that you can go to the Discord. You can join Discord for NimForUE engine, and the same link is also here in the official repository for it. You can just go on Discord, and especially the author of the library, he's awesome. He's gonna take time and explain things to you. So I asked him around, and turns out that right before last stream, I updated Visual Studio, and because of that, I guess it installed extra version of Visual Studio. So I have two versions of the compiler for C++. And, Unreal Engine can handle that, automatically, because it handles everything automatically. But in case of Nim was a little confused. So what we can do is go to our project. Okay. It was Nim Streams. And did I zoom in or not? Oh, now I zoomed in. Okay. So now project. What we can do is go to NimForUE Engine. Sorry, the plugins. And NimForUE Unreal Engine. Now there's way more files than there were before because we already ran the command once. So one of the generated files is toolchain directory. If we're gonna open it, I'm gonna open it with VS Code. Okay. How can I make it nice size for that little window? Something like, oh, come on. Something like this and that. There we go. Okay. So this basically has the link to which compiler Unreal Engine selected. So we can copy that number. Okay. And we don't need that file anymore. And what we can do is go to back to our directory of our project. Go to NimForUE Engine. You can see the game.nim. This is the code that will be actually, this is like our entry point for the game, what Nim uses. So we're gonna go and I will actually open the whole thing with code. Okay. Yes, trust the authors. And we have the whole directory open. Okay. So we can create a new file. We'll call it game.json. This is like a configuration file. So I'll maybe make it full screen. Okay. And in the documentation, I wrote it down. There's a configuration file. It describes what things are doing. And this is what we need to put in there. So let me just put that little file that we copied. I'm gonna copy this whole thing. And VC toolset. It's already different than when I ran it last time. For things like extra module names, we don't need anything. The same thing for extra non-BP module names. Let's not worry about it now. We don't need anything. All we care about is that version. So if you're trying to install NimForUE Engine and it doesn't work, or maybe you already had it installed and suddenly Visual Studio updated and everything stopped working, this is what you can add to your game.json. So that's that part. Also, at some point, I guess with earlier versions of the Unreal Engine, there was an issue where you actually needed to go to the source from Unreal Engine to Nim Streams editor. I mean the editor target file. So the name of your project, editor.target.cs. Here, right now, this shows included order version, shows Unreal Engine include order version Unreal 5.4. I believe older version of Nim, for example, required it to be 5.1. So I know you're running on 5.8 in the future, and there are some issues with the library. You might need to try a few versions here to just adjust it, or this might be missing completely if you start with Blueprint project, for example. So that's the few things, but we don't need to touch that file today, I believe. So let's go back to our terminal and run the Nimble new setup again. I believe this time it's gonna work. It's just gonna take a long time. Like extra long time, because it will actually generate all the bindings. What is going on? Nobody's watching? Monday at night, nobody's watching? Or for some, it's probably Wednesday early morning. Okay, looks like little extra window popped up. This is, I guess, the Unreal Editor.exe, and it's gonna get analyzed or whatever it's doing. I have no idea. We can see that it's running Unreal Editor, pointing to the project down here. Run generate bindings. So I don't know. Does Unreal Engine has its own bindings generation something? Who knows? But okay, that finished. It took only 56 seconds. Okay, not bad. 796 milliseconds, 562 microseconds, and 900 nanoseconds. Okay, there we go. Generate bindings for, you know, all the things like our game itself, modeling tools, AI, sounds, haptics, tests, light mass, vector field, slate, UMG, blueprints, gameplay abilities, everything. All the plugins that are enabled in our U project, bindings are generated for them. So that's awesome. Even chaos physics. So all that you can use just from Nim, which is nuts. Because I'm not a big fan of using C++ and C#. It's just so much typing. Okay, that's it. Looks like it worked properly. So we can test if it works properly. All we need to do is go to our U project and run it and see what happens. Unreal Engine should just start up normally. There we go. Okay, we've got our Unreal Engine running, right? It's all good here. I can play. And everything seems to work. I won't be sharing sounds because I'm listening to music right now, and we won't be doing much of sounds. And I'm listening to music that I can't share, unfortunately. Although I would really want to. Okay, so hey, the project works. So let's actually see if we can do something with Nim. So while we have our project open, again, the project files for Nim are in, you know, in your root directory for your project, and NimForUE, not in plugins, NimForUE. There's your game.nim. And now that the whole thing finished, we have also config nims and game.json. One thing that we're gonna add is something I can copy from somewhere else. Let me just go here, and that will be a VS Code folder. Let's paste it here. And there we go. We have our VS Code folder. What we have here, let's get rid of this. What we have here is a task. We'll call it compile game. And it basically switches to the plugins from Unreal Engine, where the plugin actually lives, and runs new game. That's the command line tool. And game will basically grab all of them code, compile it, it will compile it into a DLL that then is loaded by Unreal Engine and just hooked up while the engine is running. So no need to restarts to add new things to it. So let's try it out. The thing about it is that this is our game.nim. This is the code that's there by default for nim. We can see that there's include Unreal Prelude. We'll see a lot of that. The whole nim language server just crashes nonstop. For some reason, it just can't do anything. It just struggles. So what we have here, we include the Unreal Prelude. I guess that's the most basic types of Unreal Engine. I don't know if there are any other includes. We'll learn about it, I guess. Then we have something U class. This is basically generating Unreal Engine class called a my nim actor. It has a because it's of type A actor. So everything needs to be prefixed with an A. So there we go. Inheritance of A actors. That means that we have bindings to just generic Unreal Engine actor. And we define that it has properties. This is again macro that we would use in C++. We have an integer value and then we create a function that we can call an editor. This is exactly what it would be in C++, the same name. And those two functions, because we can provide many in here, it can be called for an editor. So we have my function and it should print out to the log hello from nim. So this was already compiled. So let's see if we can create such actor. So we can go to Unreal Engine and what we can do here is maybe right click, new blueprint class, and that must be really tiny in a stream. I am really sorry, but Unreal Engine just gets all wonky when I try to increase its display size. So let's go to all classes and search for nim actor. There it is, my nim actor. Okay, so we select, we call it BP underscore my nim actor. And let's drag it to the scene. There it is, somewhere there. But the fun part is that right here, and what do you call it, outliner? No, in the details, we have the my function, the button showed up. So let's open up the output log and let's dock it. Okay, there it is. So what happens if I'm gonna click the button? Where did my actor go? Where did it go? Ay, ay, ay. Come on, Unreal Engine. It's a bunch of stuff. Oh, there's BP my nim actor. Okay. So when I click my function, click, there it is. Hello from nim. Click it multiple times, it shows up. So that's that. So let's create another button. Okay. Let's change our code. So we're gonna go to our code. And I wonder, this is my int. Can I do something like whenever my function is called, can I do increment my int? Or do I need this or something? That's a good question because I have no idea right now. Or do I have this? I don't know how to do it. We'll see. And then let's have another proc. Display my int, okay? And we'll just log my int is, and we concatenate my int. Okay. Let's save it. I can do Control-Shift-B to compile using the command, or I can do Control-Shift-P. It'll be game. No. What was the task? compile game. Okay, so Control Shift P, compile game. Do I need to say like task? Come on. What the hell just happened? Oh, okay. That was weird. However that happened. Task. Run task. Oh, there it is. Compile game. So it's just thinking. And we got error. There we go. So Nim is unhappy. My int. Expected 1 or dose. Increment. I guess it's just not sure where my int is coming from. Can I make it this dot my int? Will this work? I really don't know how it works. So let's do Control Shift B. Nope. Self my nim actor. Maybe that's gonna work. I truly don't know. I mean, that will be the nim way, right? So maybe the nim way will work. Nope. Time to redefine self. Oh, so it has a self. So we can just do self my int. That's it. Doesn't mean that that's gonna be working. Yeah, I think that's it. Did it work? Or not? Nope, these are errors, right? Ay. Self my int is self my int plus 1. I don't think that's gonna make any difference. I guess self-mutating itself is too difficult. Hey, that worked. I just heard a dee from unknown engine. I guess we just don't have increment on integer for some reason. So let's go here. And here we already have my func and display my int. So when I click display my int is, wow, that's a large number. Okay. And I click my func, and this, it didn't change it. I guess we can't change those values just randomly. And my int was never initialized. That's probably where the big weird value comes from. But okay. Can I set it to be 0? Equals 0. Save. And compile. Well, took 6 seconds. Display my int. It's still a weird number. So let's delete it and let's create a new one, okay? Let's grab a new one. I'll click display my int. Nope. Again, weird number. Same number, huh? But we're doing weird stuff during runtime, right? I mean, not during runtime. We're doing weird stuff. So what if I'm gonna run it in a game and what was it, F12? F11? How do I exit it? Jump out. F8, there we go. So I should be able to check display my int. Still weird. Still doesn't increase it. Go figure. That's probably a weird unknown engine thing. Who knows? But the thing that matters is that, you know, we just updated a file and that's it. And we stop it. So there's also shouldn't be anything stopping us from, you know, going back, deleting this, saving, Control Shift B. All right. And come on. There we go. And it's already gone. That's how fast it goes. Another fun thing is we can just, you know what, let's copy this class. Let's create another one. we'll call it my nim actor 2. Save it. Build it. Okay. And that's built. We should already have it ready. So we go to our nim actor. We should be able to change the parent class, right? Where do you do that? Class settings. My nim actor. This is already my nim actor 2. Reparent. Bam. That's it. We were able to add a new class to Unreal Engine without, you know, closing the engine, without weird compilation issues. I don't know how much of that is still true, but just like that, we just added it there, and there it goes. I just wonder how it goes with references. What's gonna happen if I'm going to remove this actor here, the first one, because we reparented to actor number 2. So in theory, we should be able to just throw this on out. Or will we have errors? Okay. That compiled. Unreal Engine still works. Can we get back to our thing and reparent it again? Class settings. My nim actor. Oh, the first one still exists. Huh. So I guess this is where we need to be careful. Okay. I guess when we're removing, we'll need to go and close the editor, start it up again. So let's compile it with this one, okay, with number 2. What's going to happen if we're going to close it? Okay. And what happens if I'm just going to rebuild? Will it start the engine? I don't think so. No, it just builds the project. So I can quickly go and starts up the engine again. Now let's see if our... Okay, nothing crashed yet. Good. And then we go with my nim actor. Still the my nim actor 2. Let's go to class settings and my nim act. There we go. There's no previous class, so that works. So now we know that if we delete a class, we need to restart the editor. So that's that. But now that we have project set up, I would like to try to do something with like blueprint library, because that would be fun. Although I don't know if I have any specific project, because this whole thing is done with what do you call it? This is all done with C++ because it's a C++ project. But maybe we could add some functionality that you know, has something more like what would you call it? Something fun. Okay, so we have all those boxes around, right? What if we were able to press a button and make something go boom? Okay, like leave a bomb or something. So let's do it as if we were doing it normally. So we go to our content drawer. Let's just go to contents and make like a new directory, new folder. Let's call it grenade or bomb. Okay, now it's gonna be easier. And here we're gonna create a new blueprint class. It'll be an actor because we want to drop in a world. Okay, let's open it up. Let me just go to settings and is it editor preferences? Tab. Or maybe that was in project settings. Tab. Editor, blah, blah, blah. Nope. Interesting. I don't remember where it was now. With just to make it, those tabs always show up. No keyboard settings, loading, saving, animation, dock. Huh. I don't remember. I guess we can search it later. So let's just add some kind of, I don't know, ball to it. Can we add like a sphere? There we go. We have a sphere. So that will be our sphere. Let's make it a little bit smaller because this is probably like 1 meter or something. 0.15, 0.15, and 0.15. Okay. We have our scale. Okay, so this will be our bomb. And let's think about it. How will we do it in blueprints? I'm really rusty with Unreal Engine, so I'm guessing a lot now. So what I would do in our event graph, do we have something called delay? Delay. There we go. Delay, let's say it will be 2 seconds. Okay, it will be from event begin play. Whenever we create it, 2 seconds later, we want to explode. So can we do like force? Add force, add radial force component. Creates a new component, assigns ownership to the actor. This physics constraints, add force. Location, add radial force. Maybe that's it. Add force to all bodies in this component originating from the supplies. All bodies in this component. What? I want to add force. I guess we could just grab all the things around and just shove them. Well, let's see what this does. Radial force. Origin. I want origin to be get actor location or something like that. And itself, it's gonna be sphere for target. Radius, this is centimeters, so let's do 300. Oh, sure. Strength, I don't know what strength needs to be. I'll put in a large number. And yeah, so let's compile it, save it, and let's see what happens if I'm just gonna straight up drop it here. Play. And nothing happened. Of course. Let's add like a print text. Boom. Save, compile, run. Oh, boom showed up in top left corner. Okay. So, yeah. There was a boom, nothing exploded though. So, so instead of doing that, we can do something simple. More in a way of grab each object, get their center, and just apply force to them, right? So how can we do that? Let's remove that radial force, because I would like to do something in blueprints and then try to translate it to Nim to see how we can do that, or like make little library that will make it easier next time. So let me think. Can we just get overlapping actors? We could probably add something like sphere collision. Sphere generally used for simple collision. Bounds are rendered as lines. No, we want trigger, right? Trigger. No. What was the thing? Plane, camera, or box collision. We might be using collision, right? Box. Yeah, so let me just ask ChatGPT, because as far as I know, ChatGPT is pretty good with Unreal Engine, because there are so many people asking so many questions for so many years that it actually starts to work out. I want to add a spherical overlap detection zone around my actor. What blueprint component or what actor component can I use? It's a sphere component. Define a spherical collision area that can detect overlaps. Sphere component, are you sure? Sphere component. Static mesh component is used to create an instance of use static. No. Let's do the collision, okay? Let's call it sphere collision. In the viewport, we can see the size of it. So let's do something like 15. Okay. Let's do 25. Okay. A large collision. And what settings do we have here? Shape and whatnot. Start with tick enabled, whatnot. Physics, don't simulate. Don't enable gravity. What the hell? I mean, simulate physics is off. Collisions. Simulation generates hit events. Generate overlap events. That's it. We want overlap. Overlap all dynamic. Yes. This way, don't block them. Just overlap them. Okay. So what we could do now is, after that delay of 2 seconds, we could grab our sphere collision and get overlapping actors. There we go. So we get all the overlapping actors. And we get an array of them, okay? So that means that we can do something like for each, okay? For each of them. So we'll start it straight here. For each of the actors, we can check rigid. No. Simulate can trigger simulation, get simulation threshold. Okay, how do I? So I'm getting overlapping actors, okay? I have a list of overlapping actors. How can I check if an actor is has physics simulation enabled? Because there is simulating physics function. It's called on what? Actor's root component or any. So is simulating physics. So do we have that? Is simulating? No. Of course we don't. But maybe if we'll do is simulating physics. So we have that. Oh, it just needs to get a root component out of it. Okay, sure. So if the actor is simulating physics, right? Then we want to apply force to it. So can I go to actor and apply force? That's for field, Radial force. This function will dispatch a command to the physics thread to apply linear force a point away from a position. Okay, and do we have target? Target will be this actor root component. Field system, so not that. Apply force, okay. Not field. Force. Add force, there we go. To a single rigid body, It's like a thruster. Okay, adding burst over some non-zero time. Should be called ever frame, so we didn't want to add force, right? We called ever frame for the duration of the force. Is there some like impact? Don't remember now. Sphere collision. There's a sphere, there's a location. Which am I supposed to add? I'm too dumb with Unreal Engine. Haven't done it in a long time. So let's just pick some random. Radial, no. We want to just... What's the difference between those two? No idea. Let's just do at location. It's all about spheres. What the hell? Oh, isn't that... Oh, I get it. Oh, geez. Okay, that makes sense. All the sphere collision and sphere just points to my component here. Okay, that makes sense. So, array element, rigid cast to rigid body base. Oh, geez. Actor object. How can I apply force to an actor, to an instance of actor object reference? Get root, get system physics, branch, true. Print string, oh, that's pointless. I have C++ implementation. You typically want to access the actor's root component, okay, that has physics simulation enabled, and then use add force function. Can I just do this? Add force. Force. Nope, not that. Root component. Okay. Root component. Add physics. I mean, add force. Nope. Can't add force to a root component and blueprints. Add physics component. Seriously? Static mesh component or something. So I would need to get a static mesh or something. Well, let's do something like this. Component. Static. Let's create cast to get component. Get child component. And how could I try to get a static mesh component from root component? Okay, how do I do that? Cast it to static. Oh. Oh, okay. Just cast it to static mesh component because that's probably the main one, right? So we're gonna try to do that. If it succeeded, then we can do force. Add force. There we go. Oh, yes. Oh, sudden vector. Let's just do Z is up, right? Let's just add big thing to the Z. And acceleration change, sure. Sure, compile, save, and this will be only if simulating physics, right? So let's do branch. Yeah, we just branch it and only if true. So let's see if anything happens now. I ever doubt so, but maybe we're gonna have some luck. The boom happened, but we found nothing. What are those? SM chamfer cube. So it's a static mesh, just straight up static mesh. Oh, I just discovered I really suck at our engine now. Yep. Nothing moved. Static mesh component. So let's debug. Let's see what happens. Print. And this will be something like found actor with physics. Okay. And then we're gonna do another one, which is managed to cast to static mesh. Let's see if we get anything. Nope, just boom and nothing there. Am I missing something like really obvious? I'm calling the loop. And let's just print out the actors. Can I do that? For each actor, I'm gonna print string. And let's do concatenate, append. So we're found like overlapping actor. And we'll just try to convert it here. Okay, this is already becoming a spaghetti mess. There's overlapping actor, only the boom, right? BP boom and nothing else. Yeah, so that's our problem. That's the only thing that overlaps. So our overlapping is misconfigured somehow. Okay, sphere collision. We have simulation collision. Overlap all dynamic. Yeah, that sounds good. What the heck? World dynamic. Yeah. I feel like I got wrong example to show. Because we're getting into collisions and all the ugly stuff. Let's overlap all. Will that work? Nope, we just found a single thing. It overlaps only itself. That is so weird. Well, I didn't expect that to be like that. On component, begin overlap. Print. And can I just overlap component? Because that will be more fun. Nope, nothing overlap with it. Ah, bomb sphere collision. So when they're moving, they're showing up. And that's pretty much it, right? Okay, that's progress. So I want to print out the other component. Compile, save, run. So not now. Finds me as well. That's funny. So, I guess it would need to detect. Yeah. Too bad I can't just find actors and range. Maybe we'll just search for that. Not overlap, just actors and range. Where the hell is it? How can I find all actors in range? Spherical. Get overlapping actors function on sphere component. Or use the sphere overlap actors function in C++ to achieve it. Oh no. That sucks. I must be doing something wrong. But okay, but if we have that, so let's not worry about the fact that we can't find everything. Let's just make it so that when we detect it, we actually apply the force, okay? So instead of finding all the actors and doing all that stuff, having the whole for each loop, whatnot, we already have the actor, right? Primitive component object reference. So let's try to plug it in somewhere here. We know that physics will be enabled on it, so we don't even need to worry about that. Okay. We have the physics. All we need to do is cast it to static mesh component, I guess. Couldn't hurt. And try to apply the force. Would that work? Let's just grab the component. Okay. And maybe that's just gonna start sending stuff far, far, far away. Not me. Nope, nothing. Unreal Engine, why are you so non-cooperating? No, I'm wasting time trying to make something work that clearly doesn't want to work. Ay, ay, ay. Okay, let's think about different solution. Yeah, maybe something simpler, somewhere where we don't need to deal with the stupid collisions and stuff, okay? So let's do it in a way that we just get rid of this actor. We forget about the whole code. It doesn't exist. Delete it. Be gone. Save all. Let's create a new actor. Yeah, blueprint class. Let's call it. No, something where we can use code, right? Because if we're gonna make an elevator, we're just gonna make the whole weird thing. Why suddenly I don't have an idea on what to do here? Because the moment we want to do stuff with vectors, that means that we need to do weird stuff, and I don't have a brain for that today. I don't want to do text stuff because that's kind of boring. Yeah, let's do something weird where we just can point at something and something will just try to go and fly there, okay? Just as simple. Let's do it BP. Rocket, okay? Let's just create some random rocket. Again, we'll start by a sphere, okay? I'm gonna add sphere. It'll be body, okay? And we'll make it. Can I make this like the main component? I guess it is, right? Okay. Oh, this here. There we go. Oh, I just heard a sound that sounds like Coco Type is rating with a party of 8. Oh my goodness. Guess we got rated for the first time. Hello everyone. You found a place where I'm trying to do stuff in Unreal Engine, but I have no idea what I'm doing. So sorry about that. C-type raid. Hello, hello. Okay, don't know much about Nim. Okay, so we're gonna find out by me trying to do something in Unreal Engine and then replicate it in Nim. Because today we're trying to we set up a project in Unreal Engine and we have Nim code that we can actually write instead of C++. And it's kind of interesting. What is Nim? I guess that might be a serious question. Yeah. Nim is a programming language. And because you never heard of it, that means it's a niche programming language. I don't know if you're coming from a programming background or gaming background. That's, I guess, the big question. Nim language. It's a fun language. You can think of it as a Python that compiles down to C++ or C and is very extensible that you can do crazy macros. Okay, you're coming from the gaming, from C#. I also did most of the gaming stuff in C# back in Unity times, and now I'm just C# engineer doing boring business stuff. So how could I describe it? Yeah, think of Python with strong typing. Less of classes, more of the modern composition instead of inheritance stuff. But yeah, you can specify types, just like, you know, this is kind of like a class, an object. You can create variables, you have for loops, you have iterators, you know, for each, and you have crazy macros that you can basically create your own parts of language to do crazy stuff. And now I'm trying to figure out the NimForUE engine project, which is basically creates bindings to C++ and allows you to do everything that you can do in C++ in Unreal, but with Nim, which is simpler and harder at the same time. Because Nim is quite niche and, you know, like, sure, I have highlighting, but all the tooling breaks right now in Unreal Engine, it just freaks out. But hey, this is the class. Instead of doing C++ stuff, I have a class myNimActor. I define that there's a property of type integer and a little function that can be called from editor.logs, and this part doesn't work for some reason. And now I'm trying to find some reason to basically test some Nim code here. So I thought of an idea of just making a random rocket that we will be able to click somewhere and the rocket will just go flying there to that location. Just something that simple. Let's make it just a ball, okay? I'll make its size smaller. Okay, you're used to broken tools. Okay, that's good, I guess. I hope it's not too jank. So let's grab our rocket, the ball that is called rocket. It'll be little something. Let's just make sure that it has physics simulation, okay? And does it work? Do we have some physics simulation? Yes, it fell over and we can push it. Okay, great. We're one step towards making sports game. Halfway through. So now in blueprints, let's do something first where we just pick a random location and try to move that ball in a direction, okay? So, wow, this is 9 viewers. I never had 9 viewers, so, and thank you for helping me meet my following goal of 10 followers. Holy moly. It's my biggest audience ever. Okay, so random location or random there was something range, right? Random location point, random point in bounding box. There we go. That's a fun thing Unreal Engine allows us to do. So we'll just say that the center is 0, 0, 0 and half size will be of how many meters? Let's do 10 by 10 meters, okay? So it'll be 1000 by 1000 by 1000. And basically we do begin play. We're gonna pick the object and teleport the boulder, okay? So let's do set actor location. And we're just gonna get random location. And then we're gonna do delay. And after 1 second of delay, can we just loop it back here? Looks like we can. Oh gosh, that looks so ugly. Let's see. Oops. Let's see if it works. Oh no, now the ball will be teleporting places. And I will never find it anymore. Oh no. Oh, and location is 0, so it's probably somewhere. Let's get this location as what's the location in the world? 12, 500, okay? So let's do 1200 by 1200 by 500. Save, and let's see if we... Oh! Let's show up again. Because I saw the ball just disappear at some point. And I guess at that point it just gives up. Yep, that's me trying Unreal Engine. Unless you have some other suggestions, we can just change things up. I don't mind. 200, 200, 200. Play again. Have ball here. Okay, okay. We've got it teleporting. That's progress. Cool. So what we could do is that when we teleported, after we teleported, we could reset the speed or something, right? Can we do acceleration, set velocity? Not constraints. So let's grab our body. Set velocity. Velocity. Set physical linear velocity to 0, okay? Because I think that would be the thing that will allow us to just make it start from scratch every time. And not play here. I haven't used Unreal in years. Yeah, look at that. Now whenever it teleports, it just starts from no speed first. So let's try to do it in a way where those two nodes, set actor location and set linear physics linear velocity, are both run from Nim. And to do that, we need to first actually figure out how to do that on C++ side. So yeah, this is gonna be painful. So my approach is to just go to ChatGPT right now, because I don't want to. I want to first try to learn little bit by little bit, just to have an idea before I start searching documentation. So how can I set actor location in C++ in Unreal Engine 4? Okay, I'll do 4 because it probably has more training in 4 than 5. Okay, so we need just includes. We shouldn't need to worry about it. Access the actor. So you need a reference to the actor and set actor's location. So yeah, first of all, we need a blueprint library, right? So I have some notes where I tried to do it before to get some kind of blueprint function library. So let me show you how to do it in code. So we're gonna just create a new thing. We don't need to worry about one class per file or whatever. I guess at some point you could, but right now we can just do one thing. So in Unreal Engine, a blueprint function library just allows you to define nodes for blueprints in your code through blueprints or through C++ code. In our case, it will be Nim code. So it's a U class. So let's do U class, and we'll call it U blueprint function library. Let's call it something projectile function library. It'll be off U blueprint function library. Look at that. The AI already figures out how to do things, so that's awesome. So that's first part. This way, we already created a class. It's just one line instead of like whole process in C++. It's just horrible. And yeah, it will have U functions, but the thing is that when we're dealing with what the hell? U blueprint function library. There we go. Now it makes sense. The thing is that if we're gonna make like a proc, for example, a proc is an equivalent of a function, okay, in other languages. For some reason, Nim likes to call them proc. And we'll call it move to location, okay? We'll just do it right like that, and we don't return anything. We'll just do log move to location, okay? We'll just put in a log and that's it. The thing is that we won't be able to use it from blueprints yet, because in Unreal Engine C#, in C++, you basically need to decorate all the functions that, hey, you can, this is blueprint callable, okay? That you can actually call it from blueprint. So that's first thing. But additionally, because it's a blueprint function library, all those, they can be, you never create an instance of that class. You just need to make all those static. And Nim doesn't have concept of static functions and whatever, because it's kind of a little bit more separated. We can just add it like this. And that should do the thing, I believe. Yeah. So let's see what happens. If I'm gonna save it, Ctrl-Shift-B to recompile, and that basically recompiles a DLL that just gets plugged in, hot reloaded in Unreal Engine. So when we get back to our Unreal Engine, wherever it is, it should be already here, available. So I should do right click, what was it, the name of it? Move to location. So let's do it like this. Right click, move to location. We don't have it here, but can we do case insensitive? No. Something's not working. What is going on? Let me make sure I typed it correctly. We have view funcs and okay. Not sure at this moment. Of U blueprint function library. Let me just copy and paste that I didn't make any typos, because it compiles, so that should be fine. This specified and this specified. I wonder if I need to restart the editor, because sometimes, unfortunately, it does things of that sort. Move actor. Yeah. Let's do that. Let's close the editor. We save everything. And we restart it, and we'll see if it gets reloaded. Oh, it just crashed instead of close. Okay, that's a good sign. Doesn't mean that when we start it up now, it's gonna be crashing again. Because that's a possibility with Unreal. Especially when you have no idea what you're doing with code. Okay, let's reopen it. Can I do move to location? There we go. Move to location, default. And it does absolutely nothing. There we go. This is our thing. Okay, but at least it's executable and it shows up. So what do we need from it? We need a target, which will be an object reference. Actor object reference. Okay. So I guess that's not an actor, that's a reference. That's gonna be interesting. And then F vector for location. So let's try the location. Let's try to add the location. So we'll just specify that we have location F vector. Okay, we'll save it and let's try to rebuild it. And I'm really curious if it's gonna refresh or it's just gonna straight up require rebuild every time. Oh, look at that, it's already here. What's location? Wow, that was fast. So we can plug in our location. What else? Sweep, teleport. We don't want that. We just need it to be static mesh. How about that? We just assume that it's a static mesh. Or not. Primitive component. Body here is, don't know what type it is, but okay. Actor reference. So I wonder if I can just specify that it takes actor, which will be reference to a actor. Although I very doubt this will go. Something tells me we'll just be like, nope, no references here. There we go. Undeclared identifier ref a actor. There we go. So a actor ref. Will that work? All right, right now I'm just trying things blind because I have no idea what I'm doing, as always. Nope. So let's just try just a actor. Let's see what happens, because we should be able to just link an actor, right? Maybe it will show up magically as an actor reference for some reason. Assertion defect. Wow, that's a long error thing. What the heck? Okay, that's new. On rebuilding, just the same. Yep. Okay. So let's look at examples, because I made like started a separate little website that will be documentation for NimForUE Unreal Engine as I'm learning, and I copied all the examples. So let's look at the examples if we can see something. Blueprint type, blueprintable. We just have a bunch of values here, okay? Does anything look like an actor? A example actor pointer. PTR, that's interesting. Okay. Well, that's a constructor, so let's not look at that. PTR. Because we have a example actor, right? But we don't have the PTR defined, so maybe that's being defined automatically? That might be it. It's worth a try to just do a actor PTR. Okay. Let's see if that crashes the compiler. Hey, it compiled! Magic 3 letters, PTR. And actor. Actor object reference. So we could literally grab self. Get a reference to self. There we go. Our location will be this. We can plug it in. And we also need to turn it into primitive component object reference. So let's ask ChatGPT how to get a primitive actor. What? Be right back. I need to log in. Yeah. Just a second. This should work. Okay, there we go. So now how can I call, and what was it that we were calling? Oh, look at that. We got 3 minutes ago. Okay, I'm not too late. Kevin YG at YouTube says a actor pointer. Use that one. Thank you. Looks like we have somebody that know something about NimForUE engine? Is that a case? Okay, what was I searching for? Something called set physics linear velocity. How can I call a C++ equivalent of set physics linear velocity? Also, how can I get the primitive component object reference? Primitive component object reference in C++ from a actor pointer. U primitive component. Oh, so it'll be U primitive component PTR, right? Let's just double make sure. If I can just shove that in here. Let's try it. Can I just do a primitive component? U primitive component pointer. Save it. Let's see if it compiles. I think it does. Yep. Okay, so we figured that out. We can do stuff now. Oh, it feels so good when you're actually getting somewhere. So now how can we get it out of, because we don't want to just pass it on here. We should be able to extract it from a actor pointer as a root component to change to that. I guess. So what was ChatGPT saying? So in C++, we should be able to define set linear velocity. Okay. So my actor, parameter actor, blah, blah, blah. Primitive composition. Find component by class. U primitive component. Really? Nope. My actor tick. Okay, and then we have primitive component. And then we just set physics linear velocity. So that's what we should be able to do, right? Set linear velocity, that's the thing that we made. Set physics linear velocity. Oh, yeah, okay. Primitive component, call it on this, okay? So, yeah. So let's skip that part. Let's just implement the actual set actor location, right? Because we had it in a previous one. We just grab our actor and set new location, and we just give it the location, right? So let's see if we can do it. We'll just do actor dot set new location and location. We should be able to call that. I hope. And let's cut this guy out. We'll just shove it as a comment for future. Let's recompile it and see if that code will even start teleporting the ball. Oh, attempting to call undeclared routine, set new location. Yeah. So something tells me this is not gonna be that easy. Or ChatGPT is lying to me. How do I set the location of an actor in C++ in Unreal Engine? Let's see if it gives different result or the same thing. But set actor location. That makes more sense, right? Oh, yeah. AI is already trying to make things not work. Do we need to like extract an actor? That would be very strange. Nope, it's not a pointer because this is how we operate in pointers. Because yes, you can operate on pointers in Nim as well. Okay, time to get big guns out and actually do a normal Google search. Unreal Engine C++ set actor location. So if set actor location, okay. Oh, not blueprints. It was a bit different, right? Back and forth on Unreal Engine. No. So a vector new location. Okay. We just do that. New location and set actor location. But this whole set actor location can be called only from the actor itself. So I believe that's the big difference here. Kevin YG says you can open the plugins from Nim from Unreal Engine /source folder for reference. Oh, that could be interesting. Let's explore that. So let's go with plugins. And this is the generated source. So let's open it in new VS Code, right? And he says to search for set actor location to see how it's defined. Oh, I see what it will be. I already see the error that I made. I hope. So we have NimForUE engine, all that thing. So this is all generated, I believe. Echo tasks, or at least partially. Nims, and we have a lot. That's interesting. So let's do the search for set actor location. Ooh, that's a lot. So manual import module, game framework, set actor location, a actor pointer. Okay. They have B sweep that we would need to specify. Maybe it's optional. It's not defined as optional, so that's interesting. So, but the main difference is it's not capital S, it's lowercase s. And what was it in Nim? But Nim doesn't care about if letters are capital or not. Oh, it does. Yes, it does. The crazy thing about the Nim language, which is kind of funny, is that there's difference between this and that, between when the first letter is capital or not, but there's no difference if the others are or are not. It just cares only about the first character. Set actor location. Let me try that. If not, we're gonna try to add the other things. Okay. It found it. We just need to give it, the actor pointer. So it needs the actor pointer, but because we use dot, it already placed this one, which is an A actor pointer. Okay. Then we need sweep, which will be false, and hit result var f hit result. Oh, we really need to do that. And B teleport. Okay, Adam Wolf says on Twitch, got a jump offline. Thanks for the stream. Just followed. Hope to see your stream again. Well, see you then, and thank you for the follow. That's awesome. And for sure, I'll be streaming again. Stream every Monday, Wednesday, and Friday. And I'm slowly trying to... I stream Monday and Wednesday. It's from 11 p.m. Eastern time here in the US. And on Fridays, I try to do it 10 p.m. I know it's kind of weird hours, but that's how my time works right now. So yeah, I will definitely be doing, and I hope I'll be able to do this Unreal Engine stuff like once a week. That will keep me learning, I guess. So let's try to fill that out, okay? We have, we'll do false, then we need this thing and false. So let's do false, something, false. And that something needs to be this hit result, okay? It needs to be variable f hit result. So hit result. And what we can do is just make a variable hit result of f hit result, right? Will that work? F means it's like a struct, so it should have default values and it's going to be replaced anyway. Let's see if that compiles. If that's going to compile, I'll be really, really happy. No, it does not. Is of type bool and has to be used. Oh, duh. If it hits, we want to discard because it wants to return a Boolean value, and nim is basically oh, not everything. Oh my goodness. There we go. Thank you for saying, Kevin. I need to press one button and now you'll see the whole screen. I am so sorry. I'm wasting so much of everyone's time but just not showing it. Because I had zoomed in on one area of the screen. Sorry about that. Ay. So in the nim language, when you have a function or a proc, whatever, and it returns a value, you are forced to use it, as in to save it somewhere or use, or explicitly say that you want to discard it. So this should be it. It's progress. It detected that it returns something. Please work, please work, please work. Okay. It's compiled. So let's do this. We're gonna reuse the set physics linear velocity, and we're gonna, what am I doing here? Completed goes here. This goes here. So we can get rid of our set actor location. We just have our magical move to location. Okay, let's save it, compile it, and try to run it. There we go, it teleports. Hey, this is awesome. This is our nim code running right now. So hey, first time. First time something working. So that's fun. And now we just need to figure out how to get that primitive thing that we have, the is primitive component. So the self, which is the reference to this instance of blueprint, yeah, it should be the actor, I believe. Actor, get actor. I don't know. I guess there's like a separate thing of just getting actor yourself, but we already have the actor. So how can we get that primitive component? I guess we could get the root component, right? Get root component. And then cast to primitive component. That's so ugly. And then the cast could go here. Okay. Kevin is asking, what am I trying to do? So I have this code here. I don't know how visible that is. I would like to be able to call set physics linear velocity, or at least whatever it is on the nim side of things. And just call it call the NIM equivalent or C++ equivalent. But for that, the target specifies primitive component object reference. And blueprints are smart enough that when I gave the body, which is, itself, the static mesh, it's gonna figure out that it's the thing. While for setting the location, we needed the whole actor to set the actor's location, not just the static mesh's location. So I'm thinking that on the NIM side of things now that here I have the reference to the actor, I need to get to the root component of it or whatever. In this case, it's a root component. Cast it to this primitive component so that I can call set physics linear velocity or whatever. Although I don't know what the equivalent is in C++. That's the thing. Let's see if we can find it here. If I'll search for velocity, oh gosh, there will be so much. Woo. Set physics linear velocity. There are multiple of those. Components, manual import modules, components. Yeah, it repeats. Kevin says, I see. If you want to call set physics linear velocity, you just need to reference a U primitive component pointer. Yes, exactly. This one here. But I just need to get to it somehow. So let's grab that while we can. Because we'll need to provide a bunch of stuff, I guess. Or not that bad, actually. So in our game.nim, after we set this, I need to get the primitive component, and then we just do primitive component dot set physics linear velocity. Okay, and we just give it the vector, which will be f vector. Can we do something like 0 vector? Or do I need to do 0 vector? Possibly. The rest is fine. Okay. Okay, so primitive component. Let primitive component actor get component pointer. What the heck? AI tries to make stuff up. Get component pointer? Is there something like that? Nope. Clearly made up. So how does the casting work in C++? Or maybe I can go to the docs and check if I have examples of something like that, because that could be possible, right? Let's just look through examples. Because we had the example of an actor. Let's see if we have some stuff going on here. This is just F strings and all that stuff, so not that. Async, I don't think so, no. CodeGen, CoreU object example. A bunch of stuff here, get class name, find function by name, and all that stuff. The name of the method, usually the same as in blueprints usually. It should be getComponent by class. You think we'll just use getComponent by class? Wouldn't getComponent by class just search for everything? Let's see if we can get some docs on it. Unreal Engine. getComponent by class, okay. Is this blueprints again? How about documentation? getComponent. getComponent is actually just another alias for the untemplated find component. Okay, okay. There are no docs on that on Unreal Engine, really? Just forums, forums, forums? Or is Google just that bad recently? I guess it's gonna work. It's just for some reason when I think about get component by class, that means I will run the search. If I just want to cast the root component, I could do two. Exactly, that's what I want to do. I want to get the root component and cast it because I know that whatever the object I'm working with has the root component, and that's the thing. Yeah, get root component, that's fine. Yeah, I expect that I can call get root component. So, you know, let root component, get root component. Yeah, that will be it. But then I need to do root component dot, and that's the thing. How do I cast? Our engine casting components by class C++. Let's see. Getting components, bunch of stuff. They have cast this to that. But doesn't Nim already have its own cast? Let's see if I'm just gonna search for cast. UE cast? Ah, look at that, UE cast. We might be able to use that. If that's the case, I will be very happy. Gosh, so many windows open. So let's do UE cast, and we want the U primitive component pointer, and we're gonna cast the root component. But doesn't it return something? UE cast. We have 600. Oh dear God. Maybe there's a definition where we have UE cast. No, because it'll be T. Let's try. Oh, I see. So we have try. Oh, look at that. We have actual emojis used in code. That's awesome because Nim allows for emojis to be part of your names of your variables and types. And here they are just used as something. That's fun. That's really funny. Yeah. Try. Where is something where they are defined? I would like to see the definitions rather than proc space UE cast. Okay, there we go. So it returns pointer to T. Okay. Just like that. And wasn't there also try UE cast? No, but UE cast just does that. Yeah, pretty much all definitions are exposed with star. Yes. Okay, so if we would do... That's a good tip because we can do try UE cast and then star. And we see that it's a func. That... Object U, object pointer. And returns an option. Okay, so we just have options, not like returns true or false or something. So let's try to use the try UE cast. Okay. Let's try that. It's very curious. So let's do try UE cast. So it will be cast result. We want to cast to this from this. And therefore now we have the option. How the hell are we supposed to use option? Let's go to Nim programming language. There we go. Documentation. Where's the standard library? And we options. And we have the usage. Options. This returns an option. So let me see. Find found. Is some. Okay. Is some. So if it's not is some. Okay. If not, if cast result is some. Okay. Return. Yeah. Just like that, I hope. And then will be just get. Okay. That's our primitive component, and then we can just do the thing. Okay, this is not pretty code right now, but I guess I'm just rusty. Or like, not rusty. I never had those nim skills in the first place. Let's see if it compiles, because we just stretched a lot of stuff. Cannot instantiate. Oh. Why not? That's a new kind of error. Yeah. We just do the simple one and just let things crash. Let's see if that does anything. Nope. The UE cast is not happy. And the classic nim way, we have no definition why. Generic instantiation of view class from here. That's fine. 2132. Yeah. The UE cast is not happy. Let's just see how the UE cast is being used around. Just like that. Use struct. What the heck? I had those bell icons everywhere. Not sure why it doesn't work. Sorry to disappoint the viewers. This is just a festival of things not working. Let me see if I can have an example of something. Engine example. I don't think so. I wonder if this whole cast is used some different way or whatever. Can I do UE cast? We have PCG example has example of UE cast. There we go. Context, input data, tag data, data. Wow, okay. So that's one. Borrow example. Oh, just here, there's some UE cast. A player control, Seth, look at player control. So that should be available in a normal way, right? No big deal here. And if it's not now, then do something. And we have more casts. Okay, so PC can be nil. Okay. So what am I doing wrong? Because this looks just like all the other ones. Unless we have some weird import on top. Nope. Is it okay for me to just do this and compile, see if we can even get the root component? Okay, that worked. So that part is not bad. What is bad is this part, where I try to go away, or I try to cast. Okay. So something tells me this isn't happy. Let's look at an example of what kind of cast did we have there. A player controller. Doesn't mean that you just need to give it a EU primitive component and it's gonna automatically return a pointer. That might be the case. As I'm trying that, Kevin is writing the same thing. Okay. Okay, so now we know that UE cast expects just a class, not like a pointer class or whatever. Okay, that is awesome. So that means that we should be able to do the same. Okay, that means that this can be nil, right? If a primitive component is nil, return. Let's see if that compiles, because one of us is not nil or something. Okay, that works. So this way we don't have to deal with the whole option and getting from it and whatnot. We can just assume that it's that and just check if the pointer is null. Okay, and now we should be able to just set the physical linear velocity. Error, set physics linear velocity. Nope. Let's search for it. Did we fill it out or something? Or F vector 0 vector is wrong. I think we searched for it, right? Set physics linear velocity star. So we have a bunch of ways to define it. We have the pointer. We have one is false, one has the other default value, so that's all fine. So that means that F vector, I guess I'm doing something wrong here. Let's do 0 vector. Proc 0 vector. So that exists and returns a vector. Oh, that's right, I have the asterisk here. Wow, the problems of copy paste. Thank you so much, Kevin. I wouldn't have gotten anywhere without your help. How is it possible that there's somebody knowing Nim for Unreal Engine? Somebody else in the world. Error type mismatch. 0 vector this time. Extra given what? Right. 0 vector is just a function that just exists, right? I don't need to specify that it's on a class. This thing. Okay, makes sense. Oh, more fun error. Execution of an external compiler program. Oh, that one. Declaration set physics linear velocity. Error set function does not take 3 arguments. 3. Okay. It sounds like we have wrong bindings or something. What was the previous thing? Set physics linear velocity. Because that sounds like our nim program is fine, but the way it's running is not fine. 1, 2, 3. Or 1, 2, 3 in this case. That's an interesting one. On the bottom is just assert defect. Ay. While trying to match the argument list, EU primitive component, bool, and fname. Why doesn't it mention the vector? Engine components nim. Components nim. Binding exported engine components nim. So we have this definition. 1, 2, 3, and 4. We call it on the pointer, so that's 1, and give those. And it does not complain about nim being bad. Primitive component should be the pointer. So what if I'm going to manually just do false and make fname? False, make fname. Okay. What if I'm going to do it all manually? I expect the same problem. Yep. Okay. Sounds like bindings weren't defined correctly. Term does not evaluate to a function taking 0 arguments. And here does not take 3 arguments. Try using make f vector 0, 0, 0. We could try that. Make f vector, and we do 0, 0, 0. Yeah. Let's see if that makes a difference. If that makes a difference, I'll be surprised. Makes a difference. What the hell? What's wrong with the other one? Go figure. That means I can get rid of those. And should still work. Yep. So that means I should be able to get rid of this thing, or at least unplug it. And just do this. Compile, save, run. Yep. It resets it. That is so awesome. Who would have figured that doing this is so difficult? At least when you're starting. Yeah, errors aren't helpful, that's for sure. And it's not only for Unreal Engine. Not only in the case of Unreal Engine. Okay. So we've got that part. Now what if we want to just make it just keep following that thing? So what if we'll have something where we call it every tick, and it just tries to move the ball in some direction slowly. And instead of, calculating this and delay whatever, we'll just do it where we have a variable that we just save every now and then. So let's create, can we promote it to a variable? Promote to a variable. And we'll call it target location, okay? We'll have a vector. And that target location, we just set it to random place. Wait for a second. And set again. And we'll just forever just gonna keep saving them. Okay? And we don't do the move to location anymore. What we're going to do is do it like on tick, or just gonna move things. So let me think. So let's do it like this. We're gonna create a new function, okay? So a proc, it will be creep to location. It will take the actor and the location, okay? And maybe speed as float. Sure. There we go. So we are going to, for now, we'll be able to reuse the move to location, right? So let's do it in like a really janky, not nice way. As in, we'll just teleport it 1 centimeter every frame or something. Oh no, that means that we'll be dealing with vectors. Oof. We'll see. We need to learn vectors, I guess, in Nim. So we have the location, target location. So we need to get a current location. So actor get world location. Let's see if we have that available here. Get world location. Star. Get world position. Get actor location. There's get actor location. Okay. I will just return a vector. Okay, so that's good. Get actor location. Well, actor. So let's do current location is actor get location, and we have our location. So now we should be able to do the whole. It's already suggesting direction. Location minus current location. Okay, let's call it target location. Okay. So let's see. We have distance Time, distance by speed. See what AI will do for us and move to location. Will I compile? Nope. Magnitude. Yep. Oh gosh. It's 1:30 nearly here, and I need to start thinking about vector math. I'm not good with math overall, so bear with me. We have where we are, okay, one location, and then we have the other location. If we get, let's say, target location and we subtract this one, we're just gonna get the vector from here to there, okay? So that's our vector. So we would need to get like a little piece of it. That's the length of our speed or whatever. So, okay. So I guess that will be already something interesting to make a separate component out of that. A separate little thingy. But for now, let's do it that way, that we have that direction, right? Which is from one point to the other. Then we need to get the distance. Yeah, the distance. And then we do the distance divided by speed. And then the direction times that. Huh? Yeah, let's get to magnitude. How do we... I believe in blueprints it was just length, right? Length? Vector length? The length of the vector. Yeah, that will be it. So let's see if we have something like that here. Length. A vector length. There we go. The returns float 64. Okay. So we should do length. Okay. Let's do 64 in here as well. Okay. So we got the length. So that means that we can divide the distance by the speed, as in how many of those little distances do we want to cover, right? So we've got that. Let's keep that distance, okay? So this way we're gonna get not time, but direction fraction, I guess, right? And then we can do let step direction will be the direction fraction times direction. That's what my brain tells me. I have no idea what it works. But Kevin says you could normalize direction and multiply it by a magnitude and delta seconds. Yes, I could use delta seconds for sure. But normalized direction, that will return 1. Yeah, kind of. That's a good idea. I forgot totally about normalization. Gosh, it's been years since I did something in Unreal Engine or any kind of game stuff. I used to be good at it. At least that's what I thought. Alrighty. So let's figure out normalize. I presume it will be just normalize, right? normalize star. Yes, there is one. Okay. So yeah, so let's do, we have this, we have direction, and let's do let normalize direction, normalize, and how the hell do we get delta time now? Delta time. Delta time. Camera, common. Do I need to pass it on to the thing? I think I might need to pass it on. Unreal Engine. Tick has delta seconds, yeah. Float. And we need to pass it on. Okay. Let's see, delta seconds. And we have just a random get delta seconds. That's another option. Okay. I just don't think in a blueprint library one would get delta seconds, because it will be get world delta seconds and we took pass the world object. Yeah, it all depends on references. Yeah, or animation. Yeah, so we need to pass it in. And what is it usually is? Float 64. Okay. So let's go here and specify that we also need to provide it with delta seconds and float 64. So we get our normalized direction and we just do let step vector, I don't know, normalized direction times speed times delta seconds. There we go. All that goes away. The only thing is that we will need to let's ignore that. We also need to do choose smaller vector if the normalized one is larger. Okay, because there might be the case that when we distance is so tiny that when we normalize it, it actually grows larger. Oh, am I offline? And okay, looks like I'm back. For some reason, chat got disconnected. Very strange. Okay, so let's try it. We have our move to location, this and that, and let's see if we can compile it. Please compile, please compile, please compile. Error, normalize. For type vector. Really? Didn't I just search for that? Normalize. Star. Okay, I guess we need to do normalized. Nope. Is there a version of it that doesn't modify the... Come on, there must be something. Normalize. Normalize in place, or just normalize. So there should be. There's the edges. Normalize takes a var vector. Oh, and returns a void. Okay, so normalize is in place. That's so strange. and I can't see. So let's search online, because that might be one of those weird things where it actually is something else. C++, normalize, wait, Unreal Engine, normalize vector C++. There's normalize. Ha ha ha. Very funny. Vector. Get save normal or normalize tolerance. Let's see if we have get save normal. Get save normal. Nope. No such thing. Very strange that we don't have the normalize. That's not modifying the thing. Okay, let's try to use the one that we've got, the one that modifies it. So var normalized vector is direction. That should copy it, and therefore direction.normalize. Let's try that. Nope. Undeclared field normalize for the type vector, a vector. Very surprising. Let me just inspect my code if I'm doing something really strange here. Because I'm doing subtracting here. Does it mess it up? That suddenly... What's that message again? Undeclared field, normalize for the vector f vector type. Declared and blah blah blah. Surprising. Normal. Normal f vector. Nope, that's not it. Huh. Oh, this returns a unit normal version of the 2D vector. But do we have a 3D vector of it? I think it was supposed to be 3D. Just typo in docs. Let's do normal. Let's see if that works. Normal. Typos. Normalized direction. Oops. Normalized. Where do I have it? Save once more. So many typos. I'm missing squiggly lines like you get everywhere else. Undeclared identifier, move to location. There we go. So we should be able to do actor dot move to location. That should work, hopefully. Undeclared 13 moved location. It's undeclared. It's beforehand. What the heck? Because I'm not exporting them or something. Do I really need to do that? Maybe. Huh, now I can't parse it. Because they're, I guess, by default all exposed. Huh. It's interesting that it can't call itself. What the heck? That complicates things a little bit. Huh. Kevin says, yeah, it's one quirk about Nim and other scripting languages. It uses the name of the definition in C++ and skips the display name. Most likely, normalize is defined as normal in C++. Yes. So we figured that out. It's just now the interesting thing is that I can't call move to location from within the creep to location. Doesn't mean that I should specify them separately. I wonder if that would work, because right now the thing is that uClass is a macro in Nim. So we basically have uClass, and all the code that we write is shoved into the macro uClass that operates on the abstract syntax tree that it's taken out of this and rewrites the whole thing. So maybe it does some reordering or some other shenanigans where move to location suddenly isn't available. But the thing is that I believe we can define a function in a little bit different way that's outside of the thing. Maybe. Let's go to the docs, and I think I saw it somewhere. So what do we have? We have the uFunction type. You can specify uFunctions separately, or ufuncs or ufuncpragma, like this. And this is interesting, because I wonder if I could do it on the... If I could define something like that, excuse me, on top of the blueprint library. I don't know anything about deprecations. So I don't know if that kind of approach is deprecated or not. There are no docs for it yet, so that's the problem. I wonder if I can do just that. So first of all, let me just comment it out. Let's comment this out as well, just to see if we can compile it. To see if the creep to location will actually arrive somewhere. Okay, so that compiled, so that's good. That's some progress. So I wonder if I'm going to do something of this sort. Define out of this whole uClass, I will define proc. Let's do external creep. Okay. We'll just say that self will be... Gosh, that just sounds wrong. Yeah, there's also separate uFunctions, yeah. But I wonder if that uFunctions would also have problem with the stuff. You must specify the type and any shared meta like this proc Okay, yeah. But also there should be this. So let's try the U functions like you said. So we go here. U functions. Okay. I'll just do that. Self a example actor. Oh, that's interesting. I guess we could try that. Why not? And then we just define procs in there. Okay. So we just do this. We'll have the external creep and we shouldn't make it all capital, right? Exactly. That's ugly. So let's rename that as well. Just lowercase c. It's too late for this one because it's already in use, at least right now. Although maybe not. No, I'm not gonna touch it because I'm afraid that the whole project is gonna break itself and we're gonna lose it. I don't have it in source control yet. So we do U function. We would need to specify that it's static. And the self is U projectile function library. We'll just specify that it's some external creep, whatever, and we just copy this thing. And we shouldn't need to have anything specified here anymore. And we just have the implementation, which will just make exactly the same. Okay. Let's see if this still compiles. Invalid indentation. Where? Oh, where? Really? Oh, I see. This shouldn't be indented here. Okay. Yeah, that self probably won't work. Let's see. Maybe we'll force it to work. Because this is weird now. Okay, that works. Yeah, it's a static method, but somehow we need to point this to know which class it's a static method on. So that's why I would just think that this is probably not doing a lot in there. This is just allowing it to determine that, okay, these are being defined on the class this and that. And then the static changes things around a little bit. It, literally puts the word static in front of it, because in C++, when we define procs, unlike in Nim, we don't need to specify with the first one, like on which it's defined on. You just do move to location, whatever, and this is defined within the class, and that's the only thing you need to define it, to reference it, to have a reference to this. So I think the only thing that this part does is kind of makes generate within some kind of class, and then this just shoves static in front of static keyword in front of the whole thing. That's, I would probably expect it. So it compiled. So let's see if we can do some like external creep and stuff. Can we do external creep? Look at that. It exists. Target is projectile function library, so that worked. Huh. That's amazing. So now the question is, can I do this? And the answer will be no, because it wants to be called on this. Ay. Let's build it again. I see. Oh, I know what's going on. Okay, that makes sense actually. So that probably wouldn't work in Unreal Engine as well. So that tells me it wouldn't work in Unreal Engine. I mean, in Unreal Engine you could probably call with the name of a type, right? Wasn't there something like weird? Let me see if ChatGPT can find that, because some time ago I made like a NIM specific ChatGPT that has the docs in it. How can I define a proc on a type but not on its instance? Something like a static function in other programming languages. Let's see if that's gonna get it to some kind of spot, and if we can kind of get the definition of it with the type description. Okay, and we proc, and it starts with that. Okay, and then we just call it this as my type. I don't. Maybe it's defined that way. My type. Can I just do move to location? We have the actor here, right? But we're also gonna do the U project library. Save. And please work. Nope. It just straight up says undeclared identifier, move to location. So I really don't know how to call itself. It feels like what we would need to do is have a version of this that's not within the function library, right? So we just grab it, just random separate proc, okay? And we just give it an actor, location, all that. It's just a normal proc, no weird U function or whatever. And all that stays the same. And then from within here, I could probably just, for now on, I did, and just call actor, move to location, and just give it the location, right? What if I'm going to do that? And the same thing would be here. What's gonna happen here now? Time. Where did the time come from? What the heck? Normalize vector. Oh. There we go. But it didn't complain about the function now. Randomly compiled. External creep, right? I can just do self. And let's just do on tick. So that's gonna be horrible. Speed will be 10 per second. Delta seconds will be plugged from here, and target location will be always just get it at every frame. So we do get, okay, compile, save. I wonder if it's gonna run it, because the one thing that we have here is that inside our move to location that's not defined as a function or something, we have log that seems like a macro from Unreal Engine already. And I don't know if they work outside of stuff. So yeah, let's try it. At least it compiled. Just disappeared. So that's one thing. And our output log just keeps screaming, move to location, move to location, move to location. So the logs work. Okay. Huh. So that's external creep. Well, we could just do creep to location and have the same thing here, right? Let's just copy the code because this one is supposed to work. Yeah, it's the same code. Okay. So let's do that. And let's get rid of this whole log thing because it's just... Whew. And save, rebuild. It's interesting that it worked. I'm surprised, but like very pleasantly surprised. Okay. But rebuild. The ball is there and it just teleports away. So I guess I have something wrong with my math right now. Oh, duh, of course. Wow. Okay, I am being really dumb right now. So first of all, let's start ignore external creep. We'll just figure out a way to use it from within here. So let's do it that way. So we have our current location and we need to add the step vector to our current location instead of teleporting into the same nearly 0, 0, 0 spot. There we go. So let's save it. Let's rebuild it. Okay, this is starting to be a little bit of fun. The only thing that C++ has as an advantage is that you can just press dot and have all the options of what you can do with something. Here you can, because the whole thing just breaks. So in our rocket thing, instead of using external creep, let's do creep as in creep to location, right? The intended one. We have location, speed again, 10, and then will be, wait, this not here. Overlap, delete. There we go. Compile, save, and now it should stop teleporting like crazy. Slowly moving to a different location. Okay. That's good. Yeah. So let's do speed 1000. Because why not? And now it's going crazy because it's weird and blurry. I don't know how much you can see on the stream. But because the moving is so fast or whatnot, it just freaks out. I guess velocity zeroing isn't working properly. Unless there's some kind of other thing, but just goes crazy. So that works. So now let's do it every half a second or like 0.75, and let's expand the half size to 8000. Save and start playing. Okay, now we have a ball going, whoa, around a lot more. Did it just hit the wall and couldn't go through it? We can test that. So let's do it. Z will be instead of 500 will be, I know, 300, and we'll change Z to be only like 600, so there's less flying up and down. Because something tells me, because it has such small steps. Yep, it has small steps where it tries to teleport somewhere, but it still has physics. So there might be some kind of interesting fighting there. Gosh, this ball is weird. I would like it to start hitting the boxes because it's gonna teleport into the boxes, therefore it's just gonna cause mayhem. Okay, now the fun part of game stuff begins. We can start messing with the boxes. Now we just need to wait for it to hit the boxes. It still flies way too high up. It's 300. We'll put 200 here. Let's see what happens. Is it like smartly avoiding those boxes or something? Or is it gonna just not collide at all? Yeah, it's just not pushing them. I guess because it's teleporting into them? Oh, it pushes a little bit. Okay. Makes sense. Cool. The more fun will be to modify our Nim code and actually make it so that when we have moved to location, it sets physics linear velocity to some kind of vector, right? Let's say that it has massive velocity. But every frame is going to reset, so it's going to kind of fly a little bit on a physics simulation, hit something, and then going to reset, and it's going to be so weird. Because we're not using the physics engine as intended. Okay, I will need to start finishing soon because it's a bit late. I still have to work tomorrow. But okay, this was a little bit more fruitful than I expected, mostly thanks to Kevin YG giving amazing tips on YouTube. What the heck? Why is it going? Oh, I see. It's going there because it tries to return, but it just can't return fast enough back there because the velocity is just moving it like crazy. Huh. If I'm gonna make it 100 instead of 1000, it's gonna keep up. Okay, I really like that fast code iteration. Okay, it tries to go somewhere here, but then it just goes back. Jeez, it just shakes whenever it stops. Oh, interesting. That just doesn't bother those boxes. So that's one thing. I guess another level of that, we try to keep launching it towards the... Oh, we hit a box. That's something. Oh, can I just make a massive number of them or something? And see what happens? I'm telling you, that's the best part of the game. Not doing the work is just messing with it and seeing what the hell's gonna happen if you're gonna do something silly. Okay, let's play that. Oh, whoa, okay. Now the boxes are flying. And when we try to go somewhere, like jump, we just get pushed around. Oh, and sometimes they just make you walk on them, messing things up. Okay, cool. A little less mayhem than expected. But hey, that's fun. Okay, I need to try it. We have 80 of them? Seriously, that's 80? Holy moly. Okay, now we have 400. Yeah. Gosh, they really shake. Okay, one quick change. Random range. Random floating range. We want to range from 0.20, 0.2 to something like 1.5. So every time something happens, like the duration, whatever, it gets random. So they should start diverging and each having different times when it moves around. Gosh, that's so creepy when they just shake like that. Yeah, well, that's fun. Okay. I'll call it a win. We got our first proper, what do you call it? Node made with Nim. We learned roughly how to set up a blueprint function library. We were able to create two functions, 1 and 2. We can actually clean the code up a little bit. We learned a lot because we learned that there are variants of objects with PTR to be pointers. We learned that we need to be careful with the vector and not use the zero vector thing. I'll need to add that to documentation. When it's gonna get fixed, maybe it's gonna start working. We also learned that we can cast things using the where is it? Using the UE cast and try UE cast. So that's something worth mentioning. And that we can also, those pointers returned, they have isnil or something that we can check on things. And we learned how we can search for those definitions. So that's awesome. I also feel like, oh wow, I just got an amazing idea. Huh. Because this whole, where's the other project? This whole thing here with the documentation, the source. This, I feel like what could be done is that we could run the regular Nim documentation generator and just generate documentation for it to make it more searchable. That could be interesting to just try it out and see what happens, right? Very interesting. Very, very interesting. Huh. Crazy idea. What else did we learn? Yeah, a bunch of stuff. The big stuff was that I guess we can reference those together, at least in case of something like a blueprint function library when they are static. That's my theory, but that could be something I'll ask the author of the library to explain that. But just in case, we can move stuff to a separate normal nimproc, and that should be fine. And yeah, it's fun when it works. So that's awesome. So when it comes to Unreal Nim for Unreal Engine, I'm also working on a little video. I could probably just plop it here. I'm working on a video that just goes through installation of Nim for Unreal Engine. So something that we roughly went through the in the beginning. Come on, load. Takes forever. But yeah, I started working on that part. Let me see if I can play it too. Whatever I have If somebody's still watching and has some input, I'll be very happy to listen to it. I'll just I'll get rid of Unreal Engine in the meantime. I'll just enable the desktop audio so that you can hear, and I'll play what I have right now, although it'll probably be very choppy because not everything is cached yet. Welcome to the Nim for Unreal Engine project setup video. We'll start by installing the development branch of the Nim language. Then we're going to create a new Unreal Engine project. We'll start from a blueprint project just to show the process of converting it to C++. If you already have an existing project, you can skip parts of the video. Then we're going to install the Nim for Unreal Engine plugin. I'm also going to cover some potential issues one might encounter. We'll finish by testing the Nim code.
I really need to work on my pronunciation.
To use Nim for Unreal Engine, you need the development branch of the Nim language compiler. I will show you how to switch to the development branch using the Choose Nim tool. The Choose Nim GitHub page has clear instructions on how to install it. After you install Choose Nim, you can install the development branch of the Nim compiler by tapping Choose Nim devel in your system's terminal. On Windows, you might get some threat detection alerts. Just make sure to mark the detected file as ignored in your antivirus and retry the command. To update the Nim compiler, you can also run choose nim update devel. To check if Nim has been properly installed, we can run nim --version. This should correctly print out the version of the compiler and when it was compiled. If you don't have a project yet, you can create one now. In this case, I'm creating a new Unreal Engine 5.4 project from the first-person template. I'll create a blueprint-only project to show the process of converting it to C++, just in case you want to use Nim for Unreal Engine in your existing blueprint project. If you're starting from scratch, you can create a C++ project. Remember to give it a name. Here it's Nim Setup Blueprint. Click Create and wait for the engine to start up. Nim for Unreal Engine requires a C++ project to work properly. To convert an existing blueprint-only project, we need to create a new C.
So yeah, the thing is that in this video, I'm showing how to set things up starting from a blueprint project, just because there are many people who have just blueprint-only projects, and you know, I feel like it would be good to just share that, hey, converting it to C++ is just those few clicks and that's it. So that's my goal here. In this way, people can not only try C++, but maybe Nim, especially as time goes on and things are getting a little bit more stable, easier to use. Yeah, that's a goal here.
C++ class. Go to Tools menu and select New C++ class. Our choice of parent class doesn't matter here, so let's pick Actor and click Next. Give it a name, for example, MyCPP Actor, and click Create Class. Unreal Engine will now add C++ support to your project. Dismiss the message and click Yes to open the Visual Studio. It might take a few minutes for Visual Studio to start up and import the project. In the meantime, close the editor window. After Visual Studio calms down, switch the build target to Debug Game Editor and start the editor. This will compile the C++ code, making it ready for Nim for Unreal Engine plugin. When the editor starts up, simply close it and then close Visual Studio as well.
Yep, and I'm working on continuation. So if you have any thoughts, let me know. I'll be probably finishing the video tomorrow. I don't think I will have it ready by tomorrow, but the goal is maybe after tomorrow or something. It just takes so many hours to make one video and make sure that it has, you know, decent quality. Oh, horrible. But at the same time, at first I switched to DaVinci Resolve, and that was like way too, you know, it worked, but then I found limitations. Now I'm getting back to Adobe Premiere Pro, and again, learning experience, finding proper sounds, finding how you want transitions and whatnot, just so it's quick and easy, and then I can reuse those templates in next videos to make them faster. Figuring out voice recording, blah blah blah. It's just so many things to figure out. I think first 30 seconds of that intro took me like 2-3 hours to complete. Horrible. Now it'll probably take me, half that time. All right, but that'll be it for today. I need to sleep. I have work in the morning, and I hope you enjoyed the live stream. I hope you learned something. I for sure learned a lot. I'm considering having every Monday stream to be about NimForUE Engine. If at some point it won't be Nim and Unreal Engine, it'll be just Unreal Engine, or some variation of game dev. Maybe it'll be Monday. I'll try to do something like that. So Kevin YG says, James Gomez said choose Nim had some problems. I think it's best to download the development branch from the GitHub repo, the nightlies and Nim repo. Interesting. Personally, I haven't encountered a single error, a single problem related to the development branch through choose Nim, so that's interesting. And gosh, just the idea of trying to use, install Nim from sources. I don't know. It just kind of sounds like too much work. And with that video, I'm really trying to make it as simple as possible. I'll look into that. I'll ask around if it's actually still problematic, or maybe it's just thing from the past. Because I already had a series of issues in a few previous, few weeks before. I had various different problems in setting things up, but I asked around, seemed like few things got updated and it's better now. So I don't know. I also have an idea. I suggested it today on Discord that maybe NimForUE Engine could start getting versioned, that they're actually like separate releases, and this way it'll be easier to keep track of when things are changing, what is changing, a little change log, maybe, oh, this got added, this got fixed, something. And also it'll be easier to get back to the previous version before something broke, instead of you needing to write down some kind of commit number or whatever. So that's another idea. And I also want to, like I mentioned, I made this little documentation page. Where is it? The address is nimforue.pages.dev. https nimforue.pages.dev. Okay, that's the little documentation page that I just copy pasted a bunch of stuff. Nothing has proper descriptions yet. The only thing I actually added recently was the game.json. That's the part that I actually added and spent time describing. And to the next week throughout the week I'll be adding some more findings that I noticed during today's live stream. That's part of the goal, that I can learn some things and actually put them in here, like, hey, this kind of problem, or this needs to be solved that way and whatnot. So that's that part. And for those docs also, I'll put in a link to the GitHub for them too. Because, hey, if you have some ideas and, or you want to put some fixes, this is an open source project. So all the pull requests or reporting issues with, little findings like, okay, this could be described out in that way or something, feel free. it's not always a good idea. I need to copy and paste those links to Twitch channel as well. I keep forgetting that there are 2 separate sources, although I don't know if anybody's still watching on Twitch. Okay, so that, and we've got this link. Okay. Pasted to Twitch, and there you go. So yeah, that's that. And I'll start saying goodbyes again. Thank you for watching. Consider subscribing, consider liking the video, or, you know, if at some point you have more questions, ask as a comment for the stream or on Discord or whatnot. There's so many ways. If you're on Twitch, consider following, and see you on Wednesday, I believe. I hope. For me, Wednesday. For you, maybe it will be Thursday. So thank you for watching, and take care.